I'm Joe, and this is Sierra Specialty Auto. Welcome back to the shop. I have a bandsaw blade I bought from MSC. Supposed to be a good one, but the welding job wasn't very good. I believe the joint was welded together a little bit out of register, and the back of the blade was ground to eliminate this step to correct for the out of line weldment, but the teeth are of course offset on the one side of the weld. I should have sent the darn thing back when I got it and realized what was going on, but I had already tried to grind a ramp in a couple of the teeth on the high side, hoping that it would carry over from the low side to the high side. Now, that didn't work, so I'm going to cut that blade at the weld and grind back a little bit, and I'm going to silver solder the blade back together. I did a little research on this. I think the best place I came up with for ideas was Tom's Techniques, the YouTube channel. I'll put a link to his channel and to his video. He shows the process of silver brazing or silver soldering a blade using a jig that he made, a fixture. He didn't show any detail on making the fixture, but it's pretty simple, and I'm going to make use of the materials I have at hand, which are different from the materials Tom used. Let's go take a look at those and then go to the mill and see if I can make this work. I'm not sure quite how well I can get this to show up on the camera, but between the marks is the offset weld. If I take this piece of aluminum flat stock and draw it up the teeth, laying tightly against the teeth, it goes past where I ground down a couple of teeth trying to make a ramp, and then it stops, and it stops dead. As long as I'm holding a tiny bit of pressure on it, it hits, and that's enough, especially with the belt setup I have on my metal cutting bandsaw. That's enough to stop the blade, to make the belt slip. The blade stops. So let's take a look at the materials I've gathered. Tom made his fixture out of what looked to be about 6x6 chunk of about 1 inch cold rolled. What I have is some hot rolled. This is 5/8 by 3.5. I got a piece here about a little under 6 inches long. I'm going to use this piece of 3/4 by 1/2 inch bar stock to make a key to index in the slot on the belt sander, and on when this is installed, it'll be on the bottom. That'll register in the belt sander, and I'm going to cut a slot across here to bring the blade into the belt sander to grind the scarf on the opposing ends of the blade. Tom used an angle of 20 degrees. I've read recommendations of angles as high as 10 degrees, or I should say as low as 10 degrees. I'm going to compromise. I'm going to go for 15 degrees and see how that works. And if I don't like it, I can cut another slot. I'm going to have about a 1 inch opening here for the brazing to allow access to the joint with the torch, and that'll still have 1.25 inch bite on each side to hold the blade in position. I'm going to do similar machining here to what Tom did. He did a rabbet all the way across, and a notch here, I don't know, 3/4 of an inch deep, and he followed around that notch with the rabbet. Maybe for appearance, I don't think it was functional. Anyway, I'm going to do most of that. On the back side, I'm going to mill dado, you'd call it in woodworking, for a register for this guide bar to set in. And then I'll drill, tap, counterbore from this side for a couple of 1/4 inch Allen head cap bolts to hold this on. Well, let's see how that fits. Excellent. There's maybe 5/1000 play, or maybe even less than that, maybe 3 or 4/1000 play in there. And I had to sand this down. I had to sand this down a little bit to get it to, can you see what I'm doing? What happened to my camera angle? I had to sand this down a bit to get it to be a good fit in the slot on the sander table. So that explains why it's a tiny bit loose here. While I'm in this setup, I want to go ahead and trim the ends of this piece of stock so that it's a clean end and the same, the length matches the width of the main part. Let's take a little more. That's going to be a pretty good match. Now this is as good a time as any to find center of that part and drill. Let's see, we want to drill and tap 1/4 in this, and we'll come down through the top. We'll come down through the top with the Allen head bolts into this piece. I've indicated both sides and the end, zeroed on the end, and then backed up 100,000ths to zero again, and used the midpoint function on the DRO to find the center line here. On center we want, let's go, I think, 3/4 of an inch in from each end. So that'll be 3/4 in, 2 inches over, and that'll be 3/4 from the other end. It's 3/4. Over 2, and 2 and 3/4, 2 and 3/4 on the DRO. There it is. That ought to be 3/4 of an inch from the other end, and it is. I'm using a 120-degree center drill, and I'm taking the center drilling out to a little over 1/4 of an inch so that I have those two holes already chamfered. I won't have to do that as a second operation, or I should say third operation. Here we'll go for a number 7 tap drill hole. Crank that speed up a little more. I had it down around 1,000. Put that up around 1,500. Get the speed back up for finding centers and drilling holes. And back to the center drill. And we want 750 for the first center drill. And 750 for the second. Now I'll flip the part in the vise and find center on that hole using the drill bit in the same location. We'll turn it in that direction so that we're still the same distance from the fixed jaw of the vise. Should be able to just run down here and locate that hole plenty close enough for our purposes. Right there, whoops, let's get that chip out of there. That's nice and smooth. We'll go with that. I will use a 3/8 inch end mill as a counter bore since I don't have a proper sized counter bore. And since there are no lateral forces involved in this operation, I'm going to use the end mill in the chuck. I'm going to lower the table until I'm at full extension on the quill, and then raise the table the required depth so that I can repeat this measurement on the other hole. There, we've touched off. I'm going to bring the table up about 1/4 inch. Quick measurement of the depth of the Allen head screw says let's take a little more. Let's take 270. Once the cutter engages, it settles right down. And there's 2 and 750 again. slow that down a little bit. Yeah, that's better. All right. Yep, we're just below flush. That'll be perfect. I've set up the angle of the fixture to approximately 15 degrees by eye, just to match the angle of the gauge. Now I'll get set up behind the slitting saw to make the kerf for the blade to register. I've touched off here. I'd like about somewhere around 125 surface feet per minute on this slitting saw. It's 4 inches in diameter, so that's right at a foot in circumference. So I've got the mill set for around about 125 RPM. I'm going to set 50 thousandths cut, and we'll see how that works. Feed rate right now is 2 3/8 inches a minute. This is a 32nd inch blade, 31.25, with a dial caliper across the set of the teeth that seemed to measure about 37. I was hoping that it would be a good fit. This is a scrap of half-inch bandsaw blade, same thickness, 35 thousandths material. And it just does not want to go in there, so I'm going to have to switch to the next cutter I have is 45 thousandths. That's a little bit wider than I wanted to go, but at that depth, I just don't see it being a big issue. I have touched off here. This cutter is 3 inches in diameter, so I'm going to need to bump my spindle speed up to around 200 RPM when I start the machine. And we'll start over with 50 thousandths depth of cut. That's working fairly well. I do see an issue coming up. My cutter, the actual cutter is 2 3/4 inch diameter, and the lock nut on the collet is about 4, so that's only about 375 depth of cut I can get before this collar interferes with the top of the workpiece. So I'm going to have to adjust that. I'm going to have to let that down so that there is a good inch of clearance in here. Now I think I still have plenty of engagement in the collet for that to run through. That looks pretty good. Alright, so let's come back over here and find that height again. New height. I believe that'll work. Now we're looking for 200 depth of cut. That should be 1/2 inch deep. Let's try a 1/2 inch scale and see if it clears. That's within a couple of thousandths at the most. And this piece of 035 blade, there's a little bit of wiggle, but not much. I think there's enough curvature in this direction to these blades. By the time it gets all the way in there, especially with the 3/4 blade, it's going to be held very close to perpendicular. So I think that's pretty much done. Time to go do a temporary clamping arrangement and see how it works. This video is going to run a little bit long if we don't break it here, so let's call this part 1, and I hope you'll come back for part 2. I hope you'll comment, I hope you'll subscribe, and I do hope you'll come back again. Thank you for watching.